ESBL-producing bacteria by Preeti Nagasuru and Sarah Ash. Bacteria are prokaryotic microorganisms that can be found basically anywhere. They can be found on land in places such as grass, dirt, trees, rocks, in the sea, in animals and in the water, or in the air. They can also be found in places that are more extreme, such as volcanoes, hot springs, and even the deepest part of the oceans with tremendous pressure. Out of the many types of bacteria in the world, there are some good bacteria and there are some bad bacteria. Luckily, the body does have its own built-in defense system against the bad bacteria. This is called the immune system. The immune system is comprised of two parts, the innate and the adaptive. The innate immune system has more of an immediate response. This is unlike the adaptive immune system, which usually responds to foreign substances that the body has seen before and has responded to before, and therefore knows how to better counteract them. Unfortunately, in some cases, the body's immune system is not enough to deal with some foreign bacteria. This is when antibiotics come into play. There are two kinds of antibiotics, bacteriostatic and bactericidal. Bacteriostatic antibiotics do not kill the bacteria. Instead, it inhibits them from growing or multiplying, making it easier for the body to catch up and kill them. Bactericidal antibiotics kill the bacteria. Some of the ways it does this is by preventing the cell wall from being structured or inhibiting protein synthesis. Unfortunately, over time, due to the misuse of antibiotics as well as the natural mutations of bacteria, bacteria have been able to develop immunity to some antibiotics. This is considered antibiotic resistance. This is a very serious problem, as less and less treatments are being available to deal with infections. This is allowing more and more people to die from things that we used to be able to treat. One specific bacterial family that the CDC has deemed a serious threat is the Enterobacteriaceae. This includes many of the bacteria that produce extended spectrum beta-lactamase, also known as ESBL-producing bacteria. These bacteria are especially deadly because being ESBL-producing allows them to have defense against many common antibiotics. They are also very hard to treat, with the current most and basically only effective antibiotic being carbapenem antibiotics. Some examples of this family are E. coli and K. pneumoniae. These two are the most concerning. Many people who have infections due to ESBL-producing bacteria do have urinary tract infections, and that is the typical characteristic of one of the infections. But they can also cause other infections that are severe. For example, bloodstream infections and central nervous system infections. This is why the bacteria is considered a serious threat by the CDC. In addition to that, they're commonly found in the healthcare settings, meaning that they're around people with a compromised immune system. They also spread rapidly and can cause or complicate infections even in healthy people. There are ways to prevent the spread, though. These include consistent hand washing, making sure to wash under the fingernails, the palms, and in between the thumb and the index finger. Covering open wounds with sterile material, maintaining a low use of antibiotics, cleaning surfaces, and using tissues when coughing or sneezing. People that are higher at risk are people with cancer, recipients of stem cell or organ transplantation, as well as those undergoing treatment in the ICU. Because ESBLs can be cured using carbapenem antibiotics and rarely any other kind of antibiotics, there is a heavy reliance on them, which also is dangerous. This is because it is way more likely that they will become antibiotic resistant to the one treatment that we have for them. The entire family of extended spectrum beta-lactamase producing bacteria are gram-negative, and they have a bacillus shape that ranges from 1 to 5 micrometers. They're very resistant to B-lactam antibiotics and frequently have co-resistance to quinolones and aminoglycosides. They also commonly display multi-drug resistance and are thought to have gained resistance around the 1980s. ESBL-producing bacteria also live in the gut. This allows them to interact with other bacteria, which may also assist them in gaining antibiotic resistance. Also, when antibiotics are used, it allows the bacteria with antibiotic resistance to all culminate into the same place and exchange plasmids. This is the most plausible theory to explain where the antibiotic resistance came from. The bacteria transferred plasmids to each other in a process called horizontal gene transfer. This transfer allows one bacteria with antibiotic resistance to pass it along to others. This is how the E. coli strain ST131 combined with the enzyme CTXM. Now, on to stats and numbers. In 2017 in the United States, there are around 197,400 cases of infections due to ESBL-producing bacteria. Around 9,100 of those people died. Also in 2017, around 2,700 people in Europe died. Also, a study shows that in around 48.8% of cases, the administered treatment for ESBL-producing bacteria were inadequate. Like mentioned earlier, the one treatment for ESBL-producing bacteria are carbapenems. These are administered via IV. They are a part of the B-lactam class of antibiotics. The B-lactam class of antibiotics have a carbapenem skeleton. Carbapenems are highly effective antibiotics, and they have a broad spectrum, meaning that they're usually used for treatment of high-risk bacterial infections, and are usually only reserved for multi-drug resistant bacterial infections, as demonstrated in their use against EPEs. Strangely enough, carbapenems are similar to penicillins and cephalosporins, although those two are not effective against EPEs. The method that the carbapenems use to kill the bacteria are by binding to proteins that eventually inhibit bacterial cell wall synthesis. They are mostly used for gram-negative bacteria, but they do work on some gram-positive bacteria. Fortunately, although resistance is coming up for other B-lactams, carbapenem seems to be staying prominent. This is so good to hear, especially when there are already experimental ideas that are in the works. One of them being bacteriophages. These are natural killers of bacteria. They have been killing bacteria almost since life started on Earth. Another one is darobactin, which is a new antibiotic that shows a lot of promise. Unfortunately, due to the lack of funding, antibiotics will be harder and harder to come upon. This, mixed with the fact that most people are not aware of the severity of antibiotic resistance, makes it very hard for the common general public to acknowledge that soon an infection might be all that it takes to kill someone.